This is a presentation on the Introduction to Inductors lecture, and real-life examples will be included. So let's make some connections. Gauss's law, Faraday's law, Ampere's law, Lenz's law all led to Maxwell's theory of electromagnetism. Maxwell's theory essentially found the symmetry in all of the laws. So in Gauss's law, the electric flux through any closed surface is equal to the charge enclosed by the permittivity. Faraday's law states that changing magnetic fields create electric fields. Ampere's law states that electric currents and changing electric fields create magnetic fields. And Lenz's law states that induced currents always oppose the changes from their originating magnetic field. So James Clerk Maxwell found the theory of electromagnetism by combining all four of the laws. Magnetic and electric fields are interdependent pieces of the electromagnetic field, and changes in either field propagate through space as electromagnetic waves. Albert Einstein was quoted saying, "This change in the connection of reality is the most profound and the most fruitful that physics has experienced since the time of Newton." So now we'll look at some other discussed concepts which take us to inductors. Diodes, transistors, capacitors, resistors, and inductors. So what is a diode? It's a two-terminal electric component that allows current to flow in one direction, and we see it used in solar panels. Diodes ensure the photon energy that knocks electrons loose from the semiconductor panel material only moves in one direction, and that is toward the battery. And transistors are a semiconductor device used to switch or amplify electric currents, and we see these in iPhone microchips. And they assist in processing data, memory storage, and they manage power by acting as tiny switches or amplifiers. Capacitors are a device that stores energy within the electric field generated between its two conducting plates, and we see this in defibrillators. And they're used by storing electric energy and then rapidly releasing it to reset the heart's electrical rhythm. Resistors are a component that resists the movement of electrons, impeding upon the electric current to control the voltage in a circuit. And we see these in toasters and heaters and microwaves, and that's because the electrical resistance converts electricity into heat. And finally, inductors. Inductors are a passive electrical piece that opposes sudden changes in current and stores energy in its generated magnetic field. And we see this a lot in wireless chargers. The coil and the charger and the device that's being charged create a changing magnetic field that electricity can move through, and that is how the device is charged wirelessly. Thank you.